Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We do encourage engagement in the chat. There you will also find useful links. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and our speaker today is Jim Bennett, who's a regional cloud advocate. I'll now turn it over to Jim.
Awesome. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Welcome to this session, which I call the Be Kind-o-matic. Now, you may notice that my head is somewhat illuminated today. It's nice kind of green color. Now, the Be Kind-o-matic is here to help me be kinder, to help you be kinder. It converts what I say into a sentiment and changes the color around me. So, for example, if I say something positive like, I love you all, it's green. I would have said something negative like, oh, I hate this. It goes red. And so I can use this to help guide the people around me. And Sembis Bond says, very nice shirt, love it. Yes, we'll trade racists for refugees. There's a fantastic website called The Feminist Vibe, and they do a whole load of really great t-shirts that focus on basic human rights, feminism, things like that. I cannot recommend them enough. Absolutely fantastic shirts. I have 4 or so of them. So yes, go buy their shirts. Some of their profits is donated to charities that support human rights work. So, yes, thank you very much, Semis Bond. Yes, awesome shirt. So this is my Be Kind-o-matic. The idea is if I say something bad, I see the red light and it stops me. If you say something bad, you see the red light and it stops you. So kind of just a great fun use of wearable technology. So Jay McCormick says, amen. Yes, awesome. Welcome back, Jay. I believe you joined us last week, didn't you? So welcome back. And Ruta Wate that looks like the laugh emojis. I've got my screen really small. So yeah, welcome everyone. So glad to have you on this stream. Cool. So I'm just going to stop this demo for a second and then just take this hoodie off because these lights are great. But when you've got a green light in your face when you're trying to stream with the lights in front of you, it does get a little bit too much. So let's take this off. There we go. Now, I know Jay joined last week, but anyone else here who joined last week's stream? To kind of have an idea as kind of what this whole session is all about. Amruta says, hello, welcome. Really great to have you with us. So these streams, these kind of Wednesday streams, did one last week. Oh, let's take that off. I'm doing one today, next week, and the week after. Just kind of focusing on fun wearable technology. Jesse Gregorio says, puts a hand up. So yes, I guess you were here last week. Welcome back. Glad to have you back with us. So these sessions are all about wearable technology. Now, wearables is kind of a absolutely huge market at the moment. Apple, for example, they got into wearables with the Apple Watch, and they've sold, 11 billion watches. They're the biggest watch manufacturer in the world now or something. Fitbits have been going for years, but a lot of these wearables that we have these days are just wrist-mounted devices. Jay says, if you weren't here last week, go find it in the Reactor channel. It was awesome. Thank you very much, Jay. I really appreciate that. We try and do our best to bring you fun, entertaining, and educational streams. So thank you. Thanks, Irina. We just posted a link to the Microsoft Reactor channel if you want to go check it out. But yeah, I'm just trying to have fun with wearables that aren't wrist-mounted devices. Watches, fitness trackers, you wear them on your wrists. They're great. But I've just been trying to play with how can I build other wearable devices that just do fun and interesting things. Now, wearables actually have a bit of a special place in my heart because, where are we this arm? I have a little wearable. Try and get the camera angle right. That is a blood glucose monitor. I kind of wear it in my skin at all times, swap it out every 2 weeks, and that tells me how much glucose I have in my blood. Type 1 diabetic, this kind of thing keeps me alive. And so, wearables, things like this, kind of have a special place in my heart. So for these streams, I just wanted to build some different kind of wearables, something a bit fun, get people thinking a little bit about how we can use tech with our bodies, how we can kind of wear tech on us, how we can use it maybe with accessibility needs, things like that. Also, huge fan of lights, as you can probably tell. I have lights up there. I have a little button on my desk that if I press it, it'll start changing color. Usually a bit slow the first time. Come on, change color. There we go. It goes purple. Lots of cool colors. So I'm a big fan of lights, big fan of colors, big fan of how I can kind of integrate technology with the kind of clothes that I'm wearing. So that's kind of what inspired all these different shows. Last week's show, I focused on a subtitle t-shirt. This is the one Jay was saying was awesome. So I literally had a panel across my chest. I would speak, and then everything I said would come across my chest in subtitles. Bit of fun, few lights, but really great accessibility to help folks who just need a bit of extra help necessarily understanding me. Maybe they have hearing impairments. Maybe they're just English is not their first language, so having the text can be really helpful. Similar to the kind of closed captions you'd get on a YouTube video. If you're watching this video later on YouTube, you click closed captions. It can help you watching it sometimes. Same kind of thing on the shirt. And so today it's all about sentiment. In fact, Jay, I think it was you who asked last time, could you take what you get out of the speech to text and check it for sentiment? And that's actually what we're trying to do today. So today is all about using AI with a wearable device to detect the sentiment of what you're saying, and then use this to kind of give that visual feedback for people. Allow you to help kind of nudge you towards being kinder. And being kind is one of the greatest things you could do. Every morning you wake up, you can choose who you want to be. Always choose to be kind. So let's actually dive into the technology I've got, talk a little bit about that, talk a bit about the hardware, and then we can dive into the software and see kind of how all that works. So let me just rearrange cables on my desk, cables and cameras, and then let's show. I like your video. Thank you very much. Awesome. Thank you. Right, camera. This is what we've got so far. So this is the hardware I'm basing everything around. This is a Raspberry Pi Zero 2W. Now, I'm a huge Raspberry Pi fan. Absolutely huge Raspberry Pi fan. If anyone's seen any of my streams, I'm pretty much half my life revolves around saying Raspberry Pis are awesome. I have, I hate to think how many Raspberry Pis tucked in piles down there and in boxes and everywhere. Love Raspberry Pis. If you've not come across Raspberry Pi before, they're a UK-based company, originally started as a charity to teach kids how to code by providing low-priced hardware for kids to basically plug into their TV and learn. So the idea would be you'd buy a cheap Raspberry Pi, and obviously cheap is relative, but compared to the cost of other hardware, relatively inexpensive. $35. Buy a Raspberry Pi, plug it into your TV, plug it in to keyboard and mouse, and just code on your TV. And it absolutely just went bananas in terms of sales. Loads of kids learning to code with Raspberry Pis, and now they're shipping millions of boards every month when they don't have supply chain issues. But they're really, really great, powerful computers. This is the Pi Zero, which is the smaller form factor, slightly cheaper version of the board. The original Zero was a $5 computer, no Wi-Fi, but so cheap they actually gave it away free on the front cover of a magazine. This one is the new version of this. It's got Wi-Fi on board, Bluetooth on board, and it's based around the same processor as the Raspberry Pi 3. So it's literally the same as the previous generation of Raspberry Pis in a teeny tiny little form factor. Kind of see compared to the size of my hand. I don't have a traditional banana for scale, but these are small boards. $15 for one of these, and this is kind of the core that drives everything I do. Just taking a couple of comments here. Jay says, I need sarcasm sentiment. Yeah, we'll be coming to that later about that's hard. If that, I don't think anyone's ever built a sarcasm detector. Maybe that's something I should do on another stream, is actually try and build a sarcasm detector. Michael asks, could a Raspberry Pi 3 work as well, given the two boards have similar performance? Yes, totally. Literally, the chip inside this is almost identical to the Raspberry Pi 3 chip. The reason for the Zero is it's smaller and has a lower power draw. So if you're kind of wearing it, you want to power it from a battery pack, and then you just put whatever on the Pi, plug in the battery pack, and go. The Zeros just have a smaller power draw, which is why they're better for. But yeah, as Michael says, Pi Zero 2s are pretty unobtainable around my area. Yeah, there are a lot of supply chain issues with Raspberry Pi at the moment. I did a blog post about it. They're mainly trying to fulfill commercial orders. Yeah, people whose businesses rely on buying compute boards or other hardware. So yes, they're not easy to get. And unfortunately, there's a lot of scalpers who will buy everything and then sell it twice the price. Again, Raspberry Pi are working with their suppliers to reduce scalping, limiting it to one board per purchaser per week, things like that, to try and just cut down the amount of scalpers and make more boards available. But yeah, they are supply chain limitations at the moment. They are not easy to get. I picked this one up as soon as they were released, when you could get them. But yeah, any Raspberry Pi would work. It's just the Pi Zero is better for power draw, in terms of the battery pack to run it as a wearable device. Jay asks, this is the same unit as last week, right? Yes. So all the shows I'm doing are going to be based around this one board. And I hope nothing happens to this one board, fingers crossed, because this is my only Pi Zero. Well, my only Pi Zero 2. So I hope nothing happens to this board. But yeah, this is the same one as last week. Now, Michael, to your question about similar performance, a lot of what happens on the board, that doesn't happen on the board. A lot of this happens in the cloud. So in terms of the board, just a standard Pi Zero, doesn't need to be the 2, would work fine. You could even recreate what I'm doing with, say, Arduino as well. Obviously, not different programming language than what I'm going to show off today, but you could do it with Arduino if that's what you wanted to get hold of. Because the bulk of what happens with all this happens in the cloud, which we'll look at in a few minutes. But yeah, it's absolutely fantastic boards. Love Raspberry Pis. Big shout out to Evan Upton and the team at Raspberry Pi for what they've done. This is just really, really great bit of hardware. And so I've got this plugged in. I do have, this is the dongle for the headset. When you're doing anything with audio control, you need to have a way to actually communicate with the device. You need a microphone. Now, loads of different options of microphones you can use. I just happen to have let's show it here, a little Bluetooth headset, makes me look nice and cool, from back, as you did back in the day with my Bluetooth headset. I just happen to have one of these, which is kind of a great piece of hardware for this. And that's what this dongle is. This is for the Bluetooth headset. You could use any kind of microphone. I've got a little clip-on mic with a long lead. I could use that, plug it in over USB. So lots of microphone options, any kind of microphone that works. You could plug into this. And then I've got power. Obviously, you need to power the Pi. At the moment, I've just got it plugged into a USB hub for power. But when I'm actually wearing this, I would then just take the bog standard battery pack. Standard phone charger type battery pack, plug it in there, and you get a few hours of power out of one of those, depending on the size of the battery pack. So that's kind of the compute side of things. Let's dig a little bit into the light side of things. It's very Star Wars, into the light side. Yes, I love Star Wars, hence all the Star Wars Lego. Where's my end? Here's my end. So I've got lots of cables coming out here. I'll explain the Pi side of the cables in a second. But I follow them around. Lots of black tape. If you were here last week, you'll probably recognize all of my tape, because I can't solder for toffee. So I do everything with, with tape. Come around, and then this is the connection to the LEDs. I'm just going to turn them off for a second. So this is the LEDs that do everything. If you were here last week, I had an LED panel. It was an 8x32 LED panel. This is an LED strip. So this is a similar kind of idea, but it's available in an LED strip. Now, each one of these on here, these squares here, these are addressable LEDs. So these are RGB LEDs. So I can choose whatever color I want for them. And they're each uniquely, individually addressable. And you kind of see, I've got like an LED, and then it's got copper connections, LED copper connections, and so on. And what's cool about these are WS2812B. I think I always get the numbers run the wrong way. But they're WS2812B addressable LEDs. And what's cool about them is the very first one on the cable is address 0. Then 1, 2, and so on. And that just goes for the length of the strip. So if I've got a strip here, I think I've got about 20 LEDs on here. So they go from 0 to 19. I can cut it. If I wanted to have any 10 LEDs, I would literally cut it along one of these connections, and I would have 10 LEDs, and it'll go from 0 to 9. Or I could just add more on the end. And all the lights I've got behind me, for example, are exactly the same as this. I've just got a strip of 200 of them, and that goes from 0 to 199. And you just keep adding them on, adding them on, adding them on. So if you wanted to, say, light up your house, you would literally just buy a strip of 1,000 of these, line them around your house, 0 to 999. Not long enough, add another 1,000, and they become 1,000 to 1,999. So they're great in the fact that there's no complicated logic behind it. It's just simply, this one is always 0, this one is always 1. It's a kind of nice that you can access something like that and just extend, shorten them however you like. It's pretty cool. Now they have, see, there's the 3 copper things here. It's because there's 3 wires that essentially control everything. So 5 volt gives it power. DI is the inputs to tell it which one to light up and what color to do. And GND is the ground, makes the circuit. Now, actually, even though there's 3 connections there's actually 5 wires that come out of here. The reason for having extra wires is because these LEDs do draw a lot of power. I can't just plug these LEDs into my Pi and have them all light up. It draws too much power. Short strip, 3 or 4 LEDs can be powered through the Pi. Anything else pulls too much power and risks burning out your Pi. And so they helpfully have extra wires on there to run both power and the control. So if I follow my wires down, I might have to bend my camera a little bit. 2 of my wires come out here. I've got 5 volt and ground, and I've got these plugged into, it's just a standard block terminal to USB. So I can then plug this into another battery pack to provide the power for the lights. So that's the way there's a separate power supply for lights and for the Pi. Yeah, that way I can always be sure I've got enough power for my lights and I'm not going to draw too much and risk damaging the Pi. So that provides the power. And then the rest of the wires, I don't need the extra kind of power wire. There's 2 power wires on here. I don't need that. I just need a ground and the control wire. So the green one, the center one, the DI, direct input. If I follow that round, that goes into my Pi. Yes, it changes color to blue. I couldn't find any green wires. I've got a whole box of wires, and every green one I pulled out had the wrong end on it. So I went for blue. So I've got blue wire, and this comes into one of my GPIO pins on the Pi. GPIO, general purpose input-output pins, and these provide me control, and I can send signals down that. So that's my control signal, telling the lights to turn on and off. And then to make that circuit so that I've got things going around, I've got this ground wire that comes in, it's plugged into a ground pin. So this is the circuit for sending the control signal, and then this is the circuit for the power. And that's all the hardware. Now, let's write some code. Let's actually write some code to kind of play with the hardware a little bit. We start by just playing with the lights, and then we'll start looking at building all the bits and pieces to actually do the kind of all the sentiment analysis, everything like that. So let me just create a new folder. A new folder for that, and then let's open this in Visual Studio Code. Now, if you've not come across this before, Visual Studio Code has an extension called Remote SSH, which is absolutely fantastic. That allows you to open any folder on a remote device and run that as your development environment. And so anywhere you can SSH into, such as a Raspberry Pi 02W, you can actually run Visual Studio on it. So I'm on my Mac. Yeah. Hello. I work for Microsoft. I use a Mac. I'm on my Mac running Visual Studio Code on my Mac, but I'm actually connected to my Pi. So I am running as if I am on my Pi. If I bring up my terminal, for example, this terminal is the terminal on my Pi at 0. If I write code, edit files, I'm editing files on my Pi. If I stick breakpoints and I run the debugger, I am running that code, debugging that code on my Pi, which is absolutely fantastic. Love it to bits. Doesn't work on the old Pi 0, the original version. That didn't have enough power to run the other side of this, the kind of the server side parts of it, but works on the 02W. Better Call Sean says, I love the remote SSH extension, use it with my Pi all the time. Yeah, it is brilliant. Yeah, I can't remember the last time I actually plugged a Pi into a monitor, plugged in a keyboard and mouse, and actually did stuff. It's been a while because I do everything remotely. I install Raspberry Pi OS Lite, which is a headless version of the operating system, onto my SD card on my Pi, and just remote in with Visual Studio Code. It's so great. Now, what I'm going to do is I'm actually using .NET for this. I'm going to code everything in C#. We did the same last week, did everything in C#. Same again this week. And you can install .NET on the Raspberry Pi. For any Windows developers out there who thinks that .NET is a Microsoft thing, just on Windows, no, not at all. .NET runs Mac, Linux, Windows, whatever. So I'm running .NET on my Pi, which is very, very cool. And so what I'm going to do is I'm actually going to create a new console app. There we go. .NET new console, same as I do on Windows, and that will spin up a new .NET application. And then the way that .NET can interact with my lights is there is some IoT device bindings. So there is a package, iot.device.bindings, that allows you to interact with IoT devices. If I wanted to interact with sensors, actuators, any IoT stuff, there is probably something iot.device.bindings that allows me to do that. Yeah, so the whole .NET, there's the whole .NET IoT. You know what, let me grab a link to that and get a short link created and get that dropped in the chat for you if you want to read this. But there's a lot of stuff works on Raspberry Pi, Hummingboard, BeagleBoard, loads of devices, .NET Nano framework to work with microcontrollers, Meadow boards. Yeah, there's a lot of IoT stuff you can do on a Raspberry Pi with .NET, which is pretty cool. So that's what I'm using. And then let me just add a bit of code, which I'm not going to type the code. I'm going to copy and paste it because I am lazy. So this is a bit of code to just turn on the lights, and that's kind of what we'll start with. So bringing in, there's an iot.device.ws28xx library I can bring in, and this has various has code, to work with this LED strip. So I declare some NeoPixels, WS2812B. This is my strip. NeoPixels is the Adafruit name for it. So if you come across already got tab open. So Adafruit call these NeoPixels. Adafruit, it's a fantastic female-run tech company in New York, make brilliant devices, and they make these NeoPixels, they call them. And they do them in strips, they do panels, a whole lot of different bits and pieces. So NeoPixel is kind of the Adafruit name for it. It's kind of the generic name because WS2812B is a bit of a mouthful. So declare those. Everything's connected over SPI. So if you use NeoPixels with Python, normally you connect, you don't connect over an SPI bus, it kind of just connects directly over GPIO. .NET does everything over SPI. That's just how .NET IoT works. So I have to define some SPI connection settings and connect to the SPI bus. So that's why when I have my connections here, I have my ground on there, and this is actually connected to the SPI copy pin, the client out peripheral in pin there. So that's the one that's used to control the peripheral, which is this one here from the client, which is the Pi. You might see that still referred to as a Mozzie pin, but eventually that old naming technology is going away, which is a good thing. So it's the copy pin we're connected to. And then I just create my strip. connect to my SPI bus with my pixel count of 20. Now, the way these pixels work, we didn't really dive into this last time because I just used a NuGet package to do text across it. But the way the pixels work is it treats it as a one-dimensional bitmap. So it's, this it kind of makes sense with a strip because the whole strip is literally it's a long strip. It's one-dimensional. This is 0, 0, 1, 0, 2, 0, and so on and so on and so on. But even panels are basically one-dimensional bitmaps that kind of twist and turn. So it's defined as a bitmap, and the way we like things is we literally draw to a bitmap. So we pull out from the NeoPixels, we request the image, which is a bitmap. We then go through the bitmap and set the color of the pixels. So we've got 20 pixels. I'm setting that when you set them, it's based off Cartesian coordinates. We're one-dimensional, so we're always 0 on the y-axis, and then it's 0 to 20 to 90 on the x-axis. Set the color we want. And then once we set the bitmap, we then say to NeoPixel strip, update using the bitmap. So take the color, what I've said, and update that. And then in my code, all I've got is light them in white. So if I just run this, give this a few seconds to compile. So one of the upsides to .NET is your code is compiled, so it's faster when it runs. Downside to .NET is the code is compiled, so when you run it, it has to compile. Yeah, anyone who's a Python developer will just probably use their code just running because it's interpreting each line by line. This takes a little bit longer. So Jay asks, do the LED panels and pixels user guide tell it to use WS2812B? E.g., how did I determine that class on line 29? How did I know to use this? Great question. That should all be in the .NET documentation. So I think so all the IoT stuff, .NET is fully open source. All the IoT stuff is open source. So I'm trying to think where somewhere in here is okay. Sure, somewhere in here there was a sample for it, but maybe they've moved the sample somewhere else. So cited device bindings, because it's all kind of built automatically. Yeah, good question, actually. Good question. I cannot for the life of me remember where I actually found that. Get started. That's just an example of an LED. I think honestly, here we go. Here is in the docs. There we go. So there's the .NET IoT libraries documentation. There we go. This is what I was looking for. So yeah, we have the .NET library, the .NET IoT documentation here. So this is the .NET documentation for IoT.NET. And then I've got all the different namespaces in here. And I know they're WS2812Bs. So it was from here. Yeah, there's a lot of this kind of weirdo code name things, like a TLC 1543, but these are kind of based off the hardware. So if you've got a TLC 1543, you know to search for it. And here's the thing here. So yeah, so just in here, I could just search for, I know the WS2812Bs, search for WS28, and I'll find it all in here. So let me just get a short link creator that's much easier to read in that and get that dropped in the chat. Yeah, so the IT support, they don't support everything. Yeah, DC motors, CPU temperatures, character LCDs. They support a lot of stuff, but it's fully open source. So if there's more things that you want to do, they're always after pull requests for adding new hardware. Always raise an issue, add new hardware if there's something else in there that you want to add. They've also got slightly active Discord server. Somewhere. Wonder if they moved it. Yeah, there's a Discord server as well that you can join where you can discuss .NET IoT, which is pretty cool. I've been on there a few times to ask for help. So cool. Oh, okay. So I ran my code. It ran once. You see, my lights are lit up white. So that was the lighting up the LED. So I said white. If I do say color, let's go for yellow. Run this. These are the standard colors. If you've done anything with any kind of UI stuff, WPF, WinForms, anything like that, we're using standard system.color. This is a standard system.color. So there we go, color yellow. I'm kind of bright, so I'm not sure how easy it is to see it on there, but that is, from where I'm sitting, that's a nice yellow color. Might look better on this camera. You can see better. A nice kind of yellow color. And so we just set the color, and that then goes through and does on a per pixel basis. Now, I'm just setting all the pixels, but of course, if I wanted to have different patterns, what have you, I could just, I could program that into the colors. So I could say, for the first one, it's one color, second one's a different color, so on. So each pixel can be a different color. I don't have to have the same color on each pixel. And actually, some folks have even built games based around these. They have like a one-dimensional game or one of these long strips where you kind of have to bat, almost like Pong, batting a ball back and forward. And so when the ball comes into your strip, you kind of tap it and it goes back to the other end, and then let's tap a button, and you kind of just get a light zipping back and forward. And if you don't hit it in time, you lose, which is pretty cool. There's a lot of cool stuff you can do with these LEDs. Yeah, what we're doing with this is we're doing some AI stuff. We want to be able to take what I say and then understand that and get a sentiment out of that to find out, am I saying a good thing? Am I saying a bad thing? Yeah, this is the be kind-o-matic. We want to get things being kind. So the next step really is to work out how I can get what I say into some form of text that I could then use to actually get the sentiment, to find out whether I'm saying something nice or saying something not so nice. And for that, I'm using some things called Azure Cognitive Services. So Azure Cognitive Services is what's called pre-built AI. So the idea is we employ very smart people, way smarter than me, absolutely way smarter than me. And these people build these AI models, they host them up in the cloud, and then folks like me who have no clue what they're doing with AI get an SDK that we can use to actually access these services. So I don't have to know how it works. I just need to know what SDK to call. And Cognitive Services does a whole lot of stuff around language and text and speech and, vision. We can analyze images and describe what's in the image, things like that. There's a lot of powerful things they can do. And in fact, last week for the subtitles shirt, we looked at a service that converts speech to text. It can literally listen to the microphone, pick up what I say, send that audio to the cloud, convert that to text. And the text comes back from the cloud. And so we can see what has been said. All runs in the cloud because these are very big, very powerful models. So your Pi has to connect to some form of internet connection. Tether it to your mobile phone, something like that. So the first step really is to get that set up. Not going to dive too much into that. We looked at that a lot last week. So again, if you want to catch up on how that works, we did that in last week's video. But essentially, you go into Azure and say, create me a speech service, and it gives you a speech service. And so the code for this, let's just drop in the code for this. First thing I need to do is I need to add the SDK. So again, this is what I'm saying is, there's an SDK available, APIs available for you to call to use these AI services. So I just add the Microsoft Cognitive Services speech package, and that gives me speech recognition. I'm just going to drop in, while it's doing that, just drop in a couple of using directives. And then I'm going to add some keys. Now, when you spin up one of these services in the cloud, you have to connect to your service. You have special keys to do that. So I'm just going to grab my key from here, in there, grab my location. And this just tells the API whose it is. So this is my key. Please don't steal my key. I will rotate this at the end of the session. But this is my key and my region, and this tells the speech service that it's me. So bill me for everything, as it were. Now, when I say bill me, there's a very generous free tier. You get like 5 hours a month completely for free. So yeah, this is not going to cost me anything to run this. So if you want to learn more about this, catch up the video from last week. And then define configuration, set it up based off my subscription information, tell it that I'm speaking US English, which probably I should change that to that really, seeing as I'm speaking British English. Tell I'm speaking English, tell it which hardware I'm using, which is the plugged in hardware 10. That's just the ALSA configuration for my headset. Depending on what hardware you use, you may get a different number for that. It's if you a record minus L is the command that you use. A record minus L, card 1, subdevice 0. So card 1, subdevice 0. So connect to that and then create my recognizer. And then what I do is with this lighting thing. Fire up an event to say when text is recognized, do something. This just writes it to console for now, and then just starts listening. So it sits there listening in the background for me to speak. And then we just spin up a task that just waits. It does nothing. Just keeps the application running so it doesn't just stop. And this is all I need to actually do speech to text. So not diving in too deep. If you look at last week's video, we go into this in a bit more depth, including things like translations and other cool stuff. So I run this, just grab my uber cool Bluetooth headset. Plug that in, and then in a second, let's finish compiling. Hello world. This is speech to text. Cool. So that's the first step. I've kind of got what I'm saying and I'm converting that to text. So once I've got that, then I can do more analytics action, everything I'm doing. There's a lot of AI models that can analyze written text. Analyzing audio doesn't really happen as such. You kind of have to convert the audio to text first and then to convert it. So that's kind of the first 2 steps done. Got my LEDs. I know I can change the color of my LEDs as I need. LEDs. I've got what I'm saying be converted into text. Now I can actually do the sentiment analysis. Now I can look at, am I saying something nice or am I saying something bad? And all that is based off another AI service called sentiment analysis. So we have this Azure Cognitive Services for Language. This is a whole set of services that's based around language analysis. And we can do a whole lot of things with it. So sentiment analysis is one thing. So sentiment analysis is you take something and you just say, is it positive or negative? Am I saying a nice thing or a bad thing? And that's kind of what I want to use for this. It's kind of it's a thing called natural language understanding, and it just tells me on a scale of, it's got percentage values. What is the percentage chance this is a positive thing I'm saying? What is the percentage chance this is a negative thing I'm saying? And this is literally just based off the text. So going back to Jay's comment earlier, where is this? Yes, Jay's comment earlier about I need sarcasm sentiment. Can't do sarcasm. So this just takes text. So because it takes text, there's no way in written text to distinguish between somebody saying, this is a really great piece of technology, and yeah, this is a really great piece of technology. It can't pick up the nuance in the voice to distinguish between sarcasm and not sarcasm. So it's one of the downsides to this language-based analytics is you cannot cope with sarcasm. That's something maybe you need to build a separate AI model, a separate sarcasm detector to pick up the kind of the tone of voice that's used. Way outside of my knowledge, but maybe you could play with it one day. But that's sentiment analysis, the kind of thing we're going to look at here, just simple, negative or positive. Now, there's a lot more advanced things you can do. You can even look for object sentiment. So, for example, if I said the sentence, the restaurant was really great, but my food was lousy. Is that positive or is it negative? Restaurant is great, positive. Food is lousy, negative. So sentiment analysis will probably go Yeah, pick up the first one, maybe that's negative. Whereas you can do object-based sentiment analysis, and that would say, well, restaurant positive, food negative, and actually kind of detect those parts of the sentence. It's really very cool. And there's a load more other stuff you can do. You can extract key phrases. You can find what's called linked entities. So, pepperoni pizza, we're linking the pepperoni and pizza together. Look for named entities, detect personal identifiable information. So, if you've got social security number or driving license number, passport number, date of birth, it can pick that up. You can teach it to recognize certain other named things. So if you want to teach it technical names, drug names for medical use, things like that, it can detect all that kind of stuff. You even do text summarization. So legal teams love this, where you have a whole stack of legalese this big. It can literally convert that down and kind of shrink that down and pull out the salient points. Yeah, basically text summarization is the TLDR of text-based analytics. So lots of stuff you can do with all these things. We're just going to use sentiment analysis for now, just to kind of demonstrate everything here. Now, it's all built into one language service. So from Azure, I'm using the Azure portal, which is our UI to set up all any Azure services that you want. You can do it through the Azure CLI if you're a command line person. However you want to create it. But from here, I create a service. I search for language service. This is it here. It's our language service. Now, click create on here. Out of the box, by default, I get sentiment analysis, key phrase extraction, question answering, conversational language understanding, name entity recognition, text summarization, text analytics for health. So I get a lot of stuff out of the box. I can actually also start adding extra features like custom question answering, which is things like you can give it your all your documentation and it will build a bot for people to ask you questions and it will mine your documentation for you. Or custom text classification. So it's actually teach it what you want it to pull out of text, kind of allows you to customize the model. Don't need that, just want sentiment analysis. I then choose where I want to live, my Azure subscription, my resource group. Resource groups are a way of kind of putting everything in one bucket. And so what it means is you put all the resources for, say, one project in one resource group. Then when you finish that project, delete the resource group, and it deletes all the resources. It's kind of just a way of logically grouping and managing resources. I've got a resource group ready, put it in there. Choose where in the world you want this. We have data centers, Australia, up to West US, India, Japan, Germany, France, South Korea, South Africa. Lots of places. I'll go for West US. Then give it a name. And this is part of your domain name for this. So this has to be unique. So I could call it, BIM's sentiment analysis. This needs to be globally unique so that no one else can have the same endpoint. And then pricing tier. Now, there would normally be a free one here. I've already got a free one created. Save you sitting there watching this spin up. I've already got one created. But there is two options. There's free and there's standard. So if I actually bring up the pricing details. So the free, 5,000 text records free per month. So you can do in each text record up to 1,000 characters. So 5,000 sentiment analysis, key phrase extraction, language detection is free every month. So every month that number just resets. After that, you just spend, so sentiment analysis, $1 per 1,000 text records. So if what we're doing, 5,000 sentences free, that's good enough. If you want to have this running 24/7, you would end up having to pay for it because obviously you're using a whole lot of stuff in the cloud. You can pre-buy things. So if you're going to be doing 1 million sentences a month, you can pre-buy that for $700 each month, things like that. So, but there is this, what it means for us, there's a free tier. So it doesn't cost anything to get going with this. So you then choose your free tier in here, agree the legal terms, agree responsible AI. This is really important, is we actually require you to agree to use this responsibly. And we've got a whole lot of documentation around PII, language usage, to make sure you use it responsibly. So for example, if you're doing text analytics for personally identifiable information, you need to make sure that you keep that information safe. You need to make sure that you keep the information, mark it internally as confidential or keep it secure. All because you're using our technology to pull out personal identifiable information does not mean you do not have to obey GDPR. For example, in Europe, the General Data Protection Regulations. So you have to follow all applicable rules. And by clicking on this, you're saying you agree to use our services in a way that works with the law and uses it responsibly. You're not going to use this to the detriment of mankind. So tick that box, and then you can go off and create your service. Now, if there's any Brits on the call in true Blue Peter fashion, here's one I made earlier. So I've already got one spun up that I'm using. And then same with the speech to text, I have a key and a region that I can then use in my code to identify this as me. Okay, so let's actually put some code in there. So the first thing I need to do is I need to add another NuGet package. Azure AI Text Analytics. This contains random CS in the end. This contains all the code I need to access the language services. So let's check my building. While that's doing, we're done. Nice. So let's add a couple of using directives to bring in the APIs for this. We've got, and then same as we had to do with the speech service, I have to define keys. Slightly different API for this. I have credentials based off a key and an endpoint. And so I can go here and I can grab my key. There's a key there. And then endpoint. Just come to the Azure portal for the servers I've got. There you go. Key and the endpoint. Now, remember I said when you create this, the name has to be unique. That's because it forms part of the URI for this. So you could not create a language service called wearables because I got there first. So all the while this exists, this is now mine. You would have to call it something else. If you try to call it wearables, it would say that name is already in use. So that defines my credentials that I use to connect. I then create my text analytics client. So in here, I just say create me a text analytics client with my endpoint and my credentials. So new text analytics client, endpoint credentials. Not much code here. One line of code to kind of create this. It connects to my endpoint using my key, or authenticates it as me. And that's 99% of the code. All I need to do now is actually determine the sentiment. So what I'm going to do inside my recognized event, to kick off a background task. This runs the background. So rather than just sitting there blocking everything in the background, it'll take the text that comes back from speech to text, and it'll call analyze sentiment on it using my text analytics client. And that will then go off, send the text up to the cloud, analyze the sentiment, get the results, send that back. And then what comes back is a number of values. So the first thing is the sentiment, positive, negative, or neutral. This is a good thing, a bad thing, or a just neutral thing. And then as well, I get what's called confidence scores. So AI works on probabilities. It's not a binary this or this. It's not this is negative, this is positive. Instead, you get a confidence score. So it says, this is how confident I am, this is negative, this is how confident I am, it's positive. If the negative number is high, positive number is low, negative sentiment. Positive is high, negative is low, negative sentiment. Both kind of low, neutral sentiment. And so we can kind of see what the confidence is on those. And that's the basics of getting my sentiment analysis. If I just .NET run this and don my lovely headset, flip this on. There we go. This is a really good headset for this because it's as soon as you turn it on, it just connects the little dongle on the next to this and just works and just acts like a USB headset. It's a great little, it's from Plantronics, so it's not a cheap one. Oh, here we go. So, this is a great headset. You can see from there, I said this is a great headset. It's a positive sentiment, +1, -0. Again, I said this is a great headset, +1. This headset is terrible. Negative sentiment, 0.99%, 1% positive. Pineapple pizza is great. There you go. You heard it here first. Pineapple pizza was great. That's a positive sentiment of 1. When I said pineapple pizza is great, it said positive 1. So therefore, you are allowed pineapple on your pizza. Don't like it myself, but I'm not a gatekeeper. You want pineapple on your pizza? The sentiment analysis says it's okay. So yeah, so this is what spits out. It gives us this value, whether it's negative, positive, neutral, and then gives us the actual numbers. So here we go. Pineapple on pizza is okay, says Janiscu7. Yes. Yes. We don't gatekeep about whatever you want to put on pizza is fine. We don't gatekeep on that here. We're all friends here. So yeah, so this came out as positive because the positive probability, the confidence score on positive is 1, 100% confident this is positive. This one here thinks it's negative. It's like 58% confident there's negative, 2% confident there's positive. So it's kind of it's close. It's kind of trying to get this percentage values of everything. This one here, yeah, almost guaranteed to be negative. If I try, let's just try mixing and matching positive and negative. It's a second to start up. Pineapple on pizza is great, but running out of pizza is terrible. Running out of pizza is terrible, but pineapple on pizza is great. Okay, so you notice I said the same thing in 2 different ways. I basically said that running out of pizza was bad, pineapple on pizza was good. And if I said it with pineapple on pizza was good first, running out of pizza was bad second, so we ended the sentence with a negative sentiment, it detected this as negative. If I said it the other way around, we end the sentence with positive, it detected it as positive. So this is kind of one of the downsides to basic sentiment analysis is it's only assesses everything that it's got. It cannot do that breaking down. But that's where the whole text mining, opinion mining in text comes into. So opinion mining is where it provides more granular information about the opinions related to words, as the attributes of product services in text. So if we used opinion mining for this, it would say that the pineapple pizza, good, running out of pizza, bad. Seems to pick up the latter part of the sentence. Yeah, I think that's how it does it. It does it based off kind of how we wrap up the sentences. We end with the negative sentiment, so it picks that up as the most important thing. So yeah, so Jay, that's probably how it does it. But with a lot of these AI models, they're kind of very much a black box. Yeah, they're constantly trained and improved. But yeah, the behavior is essentially undefined with this. It's, we do not make any guarantees about what it will or won't do, depending on what you say. Yeah, it could change. Maybe they'll do an update to model next time that picks up the first part, not the second part. But really, to get when you have the multiple different parts of the sentence, you need to use opinion mining. Cool. So this gives us our sentiment. So now it's just a case of lighting everything up, isn't it? So what I can do is in my task here, I can then choose my lighting based off the sentiment. So I'm saying if our negative score is more than our positive score, so I'm not really looking at neutral right now, just as, we can play with this a bit more. But if we're not looking neutral, I'm just saying if it's more negative than positive, we create a red color based off the negative score. If it's more positive than negative, we create a red color based off the positive score and then light that up. So what this does is when we light it, it's from an ARGB, so which is alpha, red, green, blue. So brightness, red channel, green channel, blue channel. We're saying we want 255 alpha, so full brightness. If we're more negative than positive, we want to pick a redness that's based off the negative confidence. So if we're negative of 1, we want full 255 red, fully red. If we're negative of, 0.1, we want 1/10 of the red. So kind of the brightness of the red will vary depending on the confidence score of the negative. And then no green, no blue, so we're red. Same logic for positive. If positive is greater than negative, we have the green channel, which is multiplied by the positive confidence score. So one positive of 1, fully green, positive of 0.1, a tenth of the green. And then we just light the pixels. We light everything up. So Michael says, makes you wonder if you passed and submitted each sentence individually, it might be better. Yes and no. So if I actually explicitly had 2 sentences, pineapple on pizza is great, full stop. Running out of pizza is terrible, full stop. Yes, I could then have those 2 sentences. But if it becomes just one sentence, pineapple on pizza is great, but running out of pizza is terrible. It's a single sentence. How could I then break that up into the 2 particular parts? And that's kind of another area it becomes difficult. I can't just, I could certainly split the sentences and do each sentence individually, but a sentence can contain both sentiments in there. What's the classic line from the Evil Dead 3 Army of Darkness? It's good to be bad. In fact, that's even from Descendants. My daughter loves the Disney Descendants. The song, It's Good to Be Bad. In 5 words, we've got good and bad. So yeah, it's challenging. It's challenging. And then, to Jay's point earlier about sarcasm, pineapple on pizza is really great. Say it like that, and it's negative. You or I, English speakers will understand that's negative, but text wouldn't understand it as negative. So it's a really complicated problem still. It's definitely a very complicated problem space, but it's just a bit of fun to see what comes out. And then, say object mining really helps with some of this. It's just a bit more advanced. So that's my lighting thing. If I just go .NET run on this, and my headset on. Wait for this to start up. Pineapple on pizza is great. See, we go green. Lighter green because that was less positive. Oh, a little bit of red there. Running out of pizza is terrible. Running out of pizza is not so bad. It's good to be bad. Pineapple on pizza is great, but running out of pizza is awful. Running out of pizza is awful, but pineapple on pizza is great. Get in, loser. We're going shopping. Mean Girls reference there. Obviously, that's a negative sentiment. There we have it. That's how I build my Be Kind-o-matic. We have got our Raspberry Pi Zero connected to our NeoPixel strip, sewn into the hoodie so that it kind of glows when you wear it, all connected up via the internet to some Azure Cognitive Services that allow us to convert what I say into text and then run sentiment analysis on that and change the colors to suit. All built using .NET IoT libraries and the .NET libraries for connecting to the Azure Cognitive Services to do everything. 100 lines of code. You can plug it into a battery, and hey presto, there you go. You've got sentiment analysis on your head. Deniscu says that's a pineapple on pizza. Yes, pineapple on pizza emojis. Woohoo! Yay, we love that. And Jay says this is too cool. Yeah, it's pretty cool, this stuff. I absolutely love this stuff. So yeah, this is how I build my Be Kind-o-matic. So thank you very much for joining the stream. I've got some links in the chat for how you can kind of recreate this stuff yourself. And then next week, I believe I'm building a reading parrot that sits on your shoulder and reads to you. So thank you very much, everyone, for joining today.
Thank you all. And sorry, 1 second. Thank you, everybody, for joining. And thank you, Jim. If you have a moment, we'd love to hear what you have to say. We did post a survey link into the chat. The event code for this specific event is 15677. So we'd love to hear what you have to say. Thank you. Until next time.
please fill in the survey. If you like streams like this, tell us and we'll do more of them. If you don't like streams like this, tell us and we'll do less of them. We really want to take your feedback and just help make sure we're creating the kind of content that you want. So please fill it in.
Thank you.
Cool.
Bye.
Thanks everyone. Bye.